Hello, you're welcome back. All right, so now I have some question here on the screen. Okay, we are still on partial fraction, so we are being asked to express the following in partial fraction. Right now, different method, okay, of expressing a fraction into partial fraction. Okay, is what I'm gonna apply here for this question. Now, each of these question requires a particular method, right? Um, and that's exactly what I'll be doing here. Now, we'll use this to illustrate the different method of actually expressing a fraction into a partial fraction. So I'll start with the very first question, right? And that is I part of the question 1 all over x squared minus 4. All right, so I want to express this in partial fraction. The first of all, I have to actually express it as a product. Express the denominator as a product of two factors, right? You know very well that this is difference of 2 squared. This is the denominator of this fraction, something as, okay, x squared minus 2 squared, which of course is the difference of 2 squared, right? It's something as uh, x plus 2. Once you see this is called difference of 2 square, right? uh, X square minus 2 square, or any let me just a square minus b square is different of 2 square, which of course if you want to factorize it will give you, okay, a plus b and of course a minus b. So that's difference of 2 square, and that's exactly what I'm doing here now, right? So that's gonna be x plus 2 and x minus 2. So this is what I'm going to be expressing into a partial fraction. So I bring it down here. So I have 1 all over x plus 2, right? And of course x minus 2 into partial fraction. Of course we say is equivalent to a, right? A all over x plus 2, then plus b all over x minus 2. So what do I do next? I have to simplify the two fractions. Alright, the LCM of the denominator is x plus 2 and of course x minus 2. So I still need to write this down. Okay, so that's gonna still have 1 all over x plus 2 and x minus 2, right? Right, is equivalent to, okay, so I will divide this okay, x plus 2 divided by the LCM. Of course, it will cancel, x plus 2 will cancel x plus 2, and left with x minus 2. So that's gonna be a multiplied by x minus 2. This goes, this divides this, so I'm left with this, then that will be plus b multiplied by x plus 2, right? Alright, so with what we have, you know how the denominator will always cancel out. Okay, so now I have 1 is, okay, now equivalent to, or I can use equal to, right? A into x minus 2 plus b into x plus 2. Alright, so what do? I will use elimination method. Okay, so if I want to eliminate a, I'll put x to be equal to 2, so that this bracket will be eliminated. So that I have going to be equal to 2 minus 0, so a is eliminated. And of course here I have 2 plus 2, which is 4, so I'm having 4b. So that now makes b to be equal to 1 all over 4. Okay, so now if I want to find a, I have to eliminate b. So by putting, okay, by putting I put x to be equal to minus 2. Alright, so this is going to be equal to 1 is equal to a open bracket minus 2, right? Then plus, if I put minus 2 here, definitely b will be eliminated, right? So here I'm having minus 4a. So a in this regard will be this minus 4a, right? So that makes a to be equal to minus 1 all over 4. So invariably now my partial fraction now, okay, so the partial fraction of 1 all over x plus 2, okay, or better still, let me write it the way it was before. Partial fraction of s square minus 4, right, is going to be equal to a, and what I have a is 1 all over 4, then divided by that was okay, s plus 2 minus 1 over 4 divided by s plus 2, then plus 1 all over 4 divided by x minus 2. Okay, so that is that for that particular question. All right, so I hope you understand. This is just this is the same procedure with what I actually solved previously. Okay, the same procedure. Now let's look at this second question, how we are gonna solve it. So I'm looking at the II part of the question. All right, so you got 2x plus 1, then divided by x minus 1, okay, then s square. Okay, now there's a slight difference in the procedure I'm going to apply here. All right, now first of all, for this denominator s minus 1, okay, use a all over x minus 1. But for this other factor of the denominator, right, s square plus 1, because of the square of the x, okay, and of course the and the constant value, in this case I am not going to use b, okay, I'm going to use b, right, x. Why? Because you see here now x is actually squared, so it's going to be bx plus 1. So please take note of that. So anytime you have any denominator of any factor of the denominator of this form, okay, that has a square plus a constant value, okay, so that particular variable you want to use for the numerator, add s to it, then of course you plus bs plus c, please pardon me, okay. So the the b has b because the coefficient of x, then c is a constant value, right, then you now divide it by that, so please take note of that. So that means invariably now I'm looking for three I'm going to be looking for three variables a, b, and c, so please take note of that. All right, so here 3x plus 1 all over x minus 1, okay, s squared plus 1 is going to be equal to, of course, I factorize x minus 1, right, s squared, then plus 1. Okay, this divide this and left to this, I'm going to have a s squared, right, plus 1 plus b, all right, and of course into x minus 1. Okay, of course denominator goes, and left with 3x plus 1 is equal to a open bracket s squared plus 1 plus b open bracket x minus 1. Okay, so now that's I can only eliminate b using I can eliminate b using this elimination method of putting x equal to 1. So any place I see s, I put 1. That's going to be 3 times 1, right? Plus 1 is equal to a into, of course, 1 square plus 1. Alright, so 1 minus 1 is 0, so b is eliminated. So invariably I'm having 4 here. 3 plus 1, 4. And of course, this is 1 plus 1, 2, 2a. Then a now is going to be equal to 4 all over 2, which is equal to 2. Then for me to actually eliminate it is not easy for me to eliminate okay, yeah, it will be easy if I want to eliminate if I want to eliminate. No, it will not be easy. Even if I should put a to be equal to minus 1, okay, minus 1 square is still gonna give me 1. Okay, so remember I told you there are two methods of actually finding the variable of oh, that's I've made a very big mistake. A very big mistake. Please pardon me. I've entirely forgotten how my numerator was. Please pardon me. Pardon me. Alright. Okay. I have to go all over again. This was supposed to be this was supposed to be bracket bx plus c, then before I now multiply it by s minus 1. Alright, so what I'm supposed to be having here is 3x plus 1. Okay, a into s square plus 1, then of course plus bracket bx, okay, plus c, close, then I have s minus 1. Alright, so I can still eliminate the entire bracket by putting x to be equal to 1. So to make this bracket 0, once this bracket is 0, okay, this b and c inside this bracket will be 0, so I can get my a. So it's still gonna be the same thing. So I'm gonna have 3 here, 3 times 1 plus 1, okay, in this case 2. I'm having 1 square, right, plus 1, then the whole of this is 0, so I'm having now 4 is equal to 2a, which now makes a to be equal to 4 all over 2. Alright, so the question is, how do I get my b and of course a c? Alright, so to do that now, I told you there are two methods of actually handling that. It's either you eliminate or you compare coefficients. So I'm gonna try comparison of coefficients. So this is gonna be 3x plus 1. For me to actually do coefficient comparison, I have to expand everything, okay? So expanding this, I'm gonna have as square plus a multiplied by s square, that's a square, then plus a, right? Then I have to expand the other bracket too, expanding the bs multiplied by s. I have bs square, alright, bs multiplied by 1, I have bx, c multiplied by x, I have cx, then of course c multiplied by 1, I have minus c. So now I have to factorize. Remember, I'm comparing coefficients, so I have to factorize to get coefficients. How do I factorize? I have as square plus bs square. So s square is actually the variable is common, If I collect items, I open bracket, okay, for this and this, then I'm factorizing that. That's gonna give me A plus B. So I think that's another. I need to still do this minus bs plus cx. S is also common, okay. Let me start with let me plus x, okay. So this plus s is factorizing s out. That means I want to put c inside, then of course minus b, then the constant value minus c. So why do I factorize? So that I can compare coefficient, right? Comparing coefficients, the coefficient of x is 3 and the coefficient of x is c minus b. So I can simply say that c minus b, right, is equal to 3. The constant value here, just c, is just minus c, okay, is equal to the constant value is minus c, and the constant value at the other side of the equation is plus 1, okay. So I can also equate minus c is equal to plus 1. So invariably now c is equal to minus 1. So now it is not easy for me to actually get my b. So how do I do that? Okay, c is minus 1, right? Of course, from there we simply know directly b is equal to 3 minus c, right? So that's going to be equal to 3 minus into minus 1, right? Which of course is going to be 3 plus 1. Minus minus is plus, okay? 3 plus 1, which is 4. Okay, so you see how is it that this? I've gotten my c, I've gotten my b, I've gotten my a. So I can now express my partial fraction. So that means 3x plus 1 divided by, what's that? Okay, divided by x minus 1, all of s minus 1 times s square times s square plus 1. Okay, so after being split into partial fraction, okay, I have a. Of course, what was my a? Okay, well, my a is, what's my a? 2, right? I have 2 all over x minus 1, right? Then plus, remember what I have, bx, okay? That's 4x, b is 4x, bx plus c, right? C here is minus 1, okay? So bx 4x minus 1, then all over s square plus 1. So that is how. So please take note of this. So anytime you are being given any partial fraction which one factor of the denominator is of this form, okay, it has s square, has s square, right, and of course a constant time, then you use bx plus c as the numerator, then you evaluate the partial fraction. So I hope that is well understood. All right, so let's now go to the last question. Last question, the last but not the least. Okay, so I'll clean up. All right, so here I have one all over x plus 1, then of course x minus 1 all square. So don't forget that, okay, this is actually repeated for this, okay. First of all, I'm gonna have a all over x plus 1. Then of course, remember what I told you about square, okay, square, or the okay, a bracket, an expression in a bracket that is actually raised to a power, okay. So if I want to do this, I actually, okay, arrange the fraction of in an increasing order of its power, starting from the uh, starting with degree 1, okay, starting from um, the power raised, starting from the bracket raised to the power of 1, if you can still remember. So I'm going to start with SB all over, first of all, that's just s minus 1, right? Then C now increases okay, all square. So if it was cube, I would have also gone, okay, plus D s minus 1 all cube. So please take note of that. All right, so in this case we, okay, the LCM definitely will simply be x plus 1 and x minus 1 square. Okay, already this is s minus 1, okay, it is already the factor, the common factor s minus 1 square. I've actually handled this, so I'm not multiplying everything, just s plus 1 and s minus 1 square, right? So I start dividing. X plus 1 divide s plus 1, it will cancel. Then I'm now having a multiplied by s minus 1 all square, then plus, go to this b, all right, s minus 1 divide s minus 1 square, just I have just s minus 1, all right, and the s plus 1. So I'm having x plus 1 and at the same time x minus 1, then plus c, s minus 1 square cancel s minus 1 square, so I am left with s plus 1. Okay, so don't forget that 1 all over s plus 1, then x minus 1 square. So definitely they will cancel out. I have now 1 equal to a into x minus 1 all square, then plus b into x plus 1 x minus 1 plus c into x plus 1. Okay, so with what we have now, can I eliminate? Yes, I can eliminate. Okay, it's possible for me to eliminate by putting, if I should put x to be equal to, okay, if I should put s to be equal to 1, I will eliminate b. Okay, now I want to eliminate, I can eliminate a, I will eliminate both b here, b and of course a. If I put x to be equal to 1, so what I will have is 1, okay, equal to 1 minus 1 is 0, okay, so 0 square is 0, so a is eliminated. Here 1 minus 1 is 0, 0 multiplied by everything here, okay, is that makes b to be eliminated. So in this case I have 1 plus 1, so I'm left with c. That's going to be 2c, right? So that makes my c to be 1 all over 2. All right, so let's see if I can eliminate by putting x to be, okay, minus 1. If I should put x to be minus 1, I will eliminate c quite well. Okay, I will also eliminate b, then I will have a 2. All right, it's easy. All right, so put x equal to minus 1, so this is going to be equal to 1 is equal to a open bracket minus 1, right, square. So if I put minus 1, of course minus 1 plus 1 is 0, so everything here b will be eliminated. If if I put s to minus 1 here, minus 1 plus 1 is 0. C will be eliminated, so I'm only left with this. Okay, so minus 1 minus 1 is minus 2, and minus 2 square is 4, right? So I'm having 1 is equal to 4a, right? Which of course which gives me a to be equal to 1 all over 4. All right, so I cannot to get what is left now for me to get is b. All right, elimination cannot help me to get b, right? So the only way I can get b now is by comparing of coefficient. And if I'm going to compare coefficient, all right, I have only one constant here, so I'm looking for it simply means that, okay, I need to open the brackets. All right, I have to open the brackets. So let me actually divide. Okay, create a divided line here so that I'll be seeing my question as I walk. Okay, just one. Let me divide. All right, so let me open bracket. Of course, if I should open this bracket, if I should expand this is gonna give me this b into x squared minus 2x. All right, a, please pardon me, that's a. Okay, a to x squared minus 2x plus 1. Okay, try expanding that, you will have, right? And if I should expand it, this is difference of 2 square. Of course you should know that. And this b, difference of 2 square, s plus 1 and s minus 1 is difference of 2 square. That's okay, it's something as said s square minus 1 square, right? Which of course is 1. Okay, so that's difference of 2 square, then plus cx, all right, plus c. Okay, so if I should now compare coefficients, with this constant value, okay, of course the constant, okay, I've not finished expanding. Let me now expand. So I'm gonna have a multiplied by s square will give me as square, then minus 2ax plus a. All right, the same happen here. I have b square minus b, then plus cx plus c. All right, with what I have now, I want to compare coefficient, and the only value I have at the right hand side is a constant. Okay, so c is constant, minus b is constant, and a is constant. So it simply means that to combine all of it, a, which is a constant value, minus b plus c is constant, and of course it's equal to the constant value at the left hand side, which is equal to 1. So having gotten my b and c, what am I looking for? Okay, I haven't gotten a and c, it's easy for me to get my b. Okay, a, I got 1 all over 4 minus b, this is what I'm looking for, then plus c, I got 1 all over 2, right? So it's equal to 1. So I have to rearrange this equation. All right, rearranging the equation, what I will have, of course, okay, so minus b goes over to this. I'm gonna have 1 over 4 plus 1 over 2, right? If 1 comes over, it becomes minus 1. It's equal to plus b. Okay, so with LCM, 4 divided, the LCM of course is 4. 4 divided by 4 is 1. 1 times 1 is 1. 4 divided by 2 is 2. 2 times 1 is 2. 4 divided by 1 is 4. 4 times minus 1 is 1. So I'm having okay, so adding this, 1 plus 2 is 3. 3 minus 2 is of course 2. So that simply means that b is equal to 2 all over 4. Okay, so when you break it down, you have 2 divided itself 1, of course divide further is 2. So that is it. So invariably now, having gotten a, my a, b, and of course c, so I can simply say that what was my original partial fraction? Okay, 1 all over x plus 1, 1 all over x plus 1. Okay, then x minus 1 all square is equal to, okay, a, what is my a? 1 all over 4, 1 all over 4 all over x plus 1, right? Okay, then plus b. What is my b? My b is 1 all over 2, okay, x minus 1, then plus my c. What did I have in c? Okay, still 1 all over 2. So 1 all over 2 all over x minus 1 all square. So that is just I just use this example to explain all the techniques. Okay, these are the different techniques of partial fraction. All right, the technique that involve you using cx, remember, plus d, okay, or bx, depending on where that particular factor, all right, that particular quadratic expression, of course, that quadratic expression of this nature, right, it's an expression in which you will go. So depending on where it already, that means if I had, okay, let me illustrate this. Let's say I had, what I had was x minus 2, all right, then I have x plus 1, and I'm now having, let's say, 2x squared minus 1. Okay, this one will go for a, right, this one will go for b, then this one now will now go for c, but they're gonna be cx plus d. So that is how you arrange it. Okay, that is for then. If you have the one of power, let's say you have x plus 2 raised to the power of 3. Okay, you start, okay, with let's say if it is the only thing you have, then you start with a. Let's say you have, okay, if you have something before that, let's say s minus 1, so sa will go for s minus 1, then of course b will go for s plus 2, okay, c will go for s plus 2 square, then they will go for s plus 2 cube. All right, so these are just the different technique you employ when solving partial fraction. Okay, so I believe that it is well understood. We can still look at more question, possibly examination question, and that will be the next video tutorial. See you in the next video. Thank you very much.